Om Shahana Bhavatu Shahano Punaktu Shahu Birjam Karva Bahai Tejashina Vadhitamastu Ma Vidvishavahai. Om Shanti Shanti Shanti. Anindita, now you are both, so you manage your class.
Yes, sir. Thank you so much. So as we were discussing, we're going to talk about test reliability. So you already mentioned that test reliability is nothing but trying to determine whether a test is consistently measuring a single person's score in the same manner or not. So our assumption is that if a test does have the test reliability to a significant level, when we test them once, we will be able to get the same results the next time that we're testing the same person again. So
Yes.
this is our assumption. So in this regard, it is clear that we are now going to use correlation to determine whether we are seeing this consistency or not. Yes?
Yes.
So in this manner, we're going to do a little practical based on Spearman's rank order correlation.
Okay.
So can you tell me what you know about Spearman's rank order correlation?
The scores will be arranged in a particular order. Then the correlation would be performed.
Absolutely. So what is the nature of the data that we're getting?
Nature as in?
The form of the data. What would the form of the data be for calculating Spearman's rank order correlation?
Do you mean the ordinal or
Yes,
those types?
yes.
I think it is ordinal data.
Yeah, exactly. So it's going to be ordinal data since we are working with ranks. So in that manner, we're just going to do a little bit of it. We're going to pick out 5 dimensions, and we're going to see how we can calculate the test reliability. So I have a bunch of data with me already, for which we're going to go ahead with the calculation. So let me just share my screen. So is my screen visible?
Yes.
Awesome. So we have these 5 dimensions of a variable which have been tested once, and we have the second set of testing here again. So we have 2 sets of scores for the same kind of variable, as you can see here. And very clearly, this is also the formula for our rank order correlation. Rho is equal to 1 minus 6 sigma d square divided by n into n square minus 1.
Okay.
So this is essentially what we're going to calculate for our correlation to determine test-retest reliability. So as we understand that test-retest reliability here using Spearman's correlation involves ranks. We do not have ranks here. We only have scores. So these are scores that the individuals have given across, let's say, a range of 1 to 5. So therefore, we need to determine the ranks for each of these scores.
Okay.
So can you tell me what your guessing is based on how we can determine the ranks? So I'm just going to add a row here so that we can put the ranks. What would be the procedure to calculate ranks across this data? What do you think it is?
Is it something to do with the rows and columns?
No. It is just a simple formula that we use to determine the ranks.
Okay, I have no idea.
Okay, all right, that's okay. So typically when we're trying to determine the rank of these kind of data where we have multiple repetitions of the same number and therefore we should assign a same position for them, we will use the simple mechanism where we will first count how many positions we have to take. Since 4 is the lowest number out of this, we have only 4 and 5 in this data, we're going to consider 4 first. So how many 4s do we have? 1, 2, 3, 4, 5 and 6.
6, yeah.
So we have 6 positions which is occupied by 4. So what we're going to do right now is that the first 6 positions will be occupied by this number 4. So therefore, we will add the positions together. So we are going to do 1 plus 2 plus 3 plus 4 plus 5 plus 6. Right? So this is what we're going to do first. Can you tell me the total for this?
Wait 1 second. 21.
Yeah. So we're going to have this as 21. And this is going to be divided by the number of positions. How many positions are we filling in?
6.
6. So we're now going to determine this. So 21 divided by 6 is equal to 3.5. Yes?
Okay.
So each of this number 4 here will be assigned the rank 3.5.
Do we have to always take the number of lowest scores, number of lowest scores? As in, here 4 is the lowest score. That's why there are 6 4s. So we are taking 6. If in case we are having 2 3s, do we have to take only 2?
Yes, we will be considering
place
that
of
according
6.
to the number of positions needed. Because here in this data, we are again having 2 3s here, as you just mentioned. So we have 1 and 2 here, for which we'll do the similar calculation where we are adding 1 and position 2. The total will be 3 divided by 2, which is going to be 1.5. So both this 3 and that 3 will be assigned the rank 1.5.
Okay, number of lowest occupancies, we will have it as a denominator.
We're not exactly just going to focus on the lowest. So any number that you're trying to split across, that will be counted here. So here, since we have 6 4s, we're only going to have 2 5s. So the same calculation we're going to do for the 2 5s that are shared. So what are the positions that are left? 7th position and the 8th position are left.
Yes.
Yes?
Yes.
So 7 plus 8 is what we'll do right now for 5.
Okay.
Okay. So 7 plus 8 is 15.
Okay.
Which will be divided by 2 because you're only sharing this
2.
amongst
Okay.
2 positions.
Okay.
Okay. Does that make sense?
Yeah, yeah.
Awesome. So now you're going to get 7.5 for the 5th numbers here. So both the 5s will get the rank 7.5.
Okay, the rank of 5 would be 7.5.
Exactly. So the rank of 4 that we calculated would be 3.5 as we've done this entire calculation here.
Okay.
This includes the rank for now the 4 that is here in the score.
Okay, okay.
And for the 5, we have this calculation that says the rank is 7.
Okay.
So I'm just going to fill that in right here. So for all the 4s, it is 3.5. And for the 5, it is 7.5. Right. So now we have the rank. So what we need to do is we're just going to follow through with our calculation of row here, for which we need to take into account rank of data 1. So since this is the first attempt, we're going to take that as our first set of data. I'm just going to write it as, let's say, x1. Okay. So now we need to find the equivalent data. So for this particular variable, we have the equivalent data here. So I'm just going to add one more column here, and we're going to calculate the ranks again.
Why
so
do
can
we
you
need that equivalent data?
Because that's what we're trying to find out, right? This is the first attempt of the test, and this is the second attempt of the test. So correlating these two ranks is what is going to give us the reliability.
Okay.
So this is the attempt 2 that we're trying to understand now. So can you calculate the ranks for each of the numbers given? We have 3 5s and we have 1 2 3 4 5 4s. So can you calculate what would be the rank?
1 second.
Yeah.
For 4, it would be
So again, we're going to do the same thing. 1 plus 2 plus 3 plus
4
4
plus
plus
5
5.
plus, yeah, 5.
So this is going to give us a total of 15. 15 divided by 5. So the rank assigned for 4 is 3. Right?
And
So the next thing we
for
have
5 it
is
would
the,
be 1, 2, 3.
yeah, so it will be 6 plus 7
7
plus
plus
8.
8.
So that will be the total of
13.
21.
Yeah, 21.
Yeah.
21,
So 21
7.
divided by 3
Yeah,
is 7. Yeah. So we're going to assign the same things here. So for all the 4s, we're going to assign the rank 3. And for all the 5s, we're going to assign the rank 7. Right? So this one, I'm going to take it as x2 because this is the equivalent data that we need. Okay, so I'm just going to label it as x2. So now we need to find out this d squared. Yes.
Okay.
So in this formula, d squared is nothing but the square of differences. Exactly. So we need to find d first. D is the difference between these two scores. So as you can see, it is
0.5.
Yes, 0.5.
0.5. 0.5.
Again 0.5. Here we have 3.5.
Yeah. Same. Yeah, it is 4.
Yes. 4.
0.5. 0.5. 4.
4. Check again. So here we have the calculated data already. So you can cross check it here as well.
4.5.
Yeah. So we have 3.5 and 4.5 here. Right. So we're just going to do the same thing.
Okay.
Yes. So this is 4.5 and this is 3.5. Yes, this is actually minus in the sense that we have the first number smaller than the second number. Same thing happening here as well.
x2 minus x1 or x1 minus
x1 minus x2.
Okay.
Yes, so since x1 is smaller here in these two cases, it will be negative, but since we're already going to square it, it does not matter to us.
So we
I'm just
neglect the minus square.
Yes. Yes. So it doesn't matter if it's minus or plus because we are anyway going to square it. That will end up with a plus. So what is the, here D2 indicates D square because I'm unable to put that superscript there. We're just going to assume it's D square. So can you help me out here? 0.25.
0.25. 0.25. 0.25. It is 12.25. Is it 12.25? Yeah.
It is.
20.25. 0.25. 0.25 and 12.25.
Yeah, absolutely. So this is the d square that we've gotten now. So what we need right now is sigma d square, right? So we need to find the sum of these things.
Okay.
So therefore, we're just going to put out sum and enter. We have 46 as the sum. Okay. So now we need to substitute it in this formula for which we need to find out n into n squared minus 1. N is nothing but the total number of samples. So how many samples do we have here? 8.
8, yeah, 8.
Yeah. So 8 into 8 in 8 squared, which is 64 minus 1. Yes. This is what we need to find out for the denominator. Am I correct? Okay. Seems like Dharni's just left. The system may be problematic. Let's wait for it.
No.
Awesome. Welcome back.
Yeah. Yeah. Sorry, my system got disconnected.
Yeah, that's all right. It's okay. So we were talking about the denominator here, which is n into n square minus 1. So that is equal to 8 into 64 minus 1. So it is 8 into 63, which is equal to 504. Okay, so if we calculate that, it comes up to 504. So all we have to do right now is we just have to completely substitute all of these values into the formula, right? So we have 46 divided by 504, and the entirety of this value should be subtracted from 1.
1.
Yes. So
Yeah.
46 divided by 504 is 0.091. Yes, so this is 0.091. So this should be 1 minus 0.091, which is equal to
1 minus 0.091 is 0.909.
exactly. So it is 0.90. Let's just stop it with that, or we can change it to 0.91. Since our value after the 0 is 9, we can change it to 0.91. So this is the Spearman correlation value for the first dimension of this variable. Does that make sense?
Yeah.
So what do you think is the interpretation for such a correlation value here? We have the correlation coefficient at 0.91. So how is the correlation?
It is almost very good.
Exactly. So it's a very, very strong positive correlation that we've got in. So therefore, this implies that for this particular variable dimension that we've calculated the test-tree test reliability for this particular dimension, the test-tree test reliability is very good. Okay, so this is essentially what we're looking at when we say test-tree test reliability. So we're just going to do one more right now for the time that we have, and we're just going to wind up with today's class. You'll be given an assignment based on this with a little bit more of data that you will just have to calculate the test-tree test reliability in the similar manner that we've done. Right? So you can use the YouTube video as a guidance for you as you're doing the assignment, so that you can revisit whatever we're talking here.
Yeah, sure.
Okay, so we're just going to do one more, and we're just going to continue on. So for the second dimension here, we're now going to calculate the ranks. So we have 3 as the single place here. So 3 being the lowest number with being only one occurrence, its rank is going to be 1. Okay, so we have 4 occurring twice. So we need to calculate the position for 4, which is 2 plus 3 divided by 2.
Yeah.
Which is 5 divided by 2 is 2.5. Yes, so it's going to be 2.5. Now we have to look at the number for 5. We have 1, 2, 3, 4, and 5 times
5.
that we have 5 occurring. So which are the positions that it's taking? We have already taken 1, 2, and 3 positions as of now.
It is
So
like 2, 3.
we have to take from 4, right? So 4 plus 5 plus 6 plus 7 plus 8.
Okay.
Yeah. So this is the positions that we have to assign for 5. The total is 30. Yes. So 30 divided by 5 is what we're going to assign as a rank. Exactly. So the rank is 6 here. So again, I'm going to copy this data to be my initial data. I'm going to do it again here a little bit lower. So again, I'm going to label it as X1. So now we're going to calculate the next thing for emotional control here. Yes, again, we're going to calculate the ranks. So here we have the third number occurring twice. So we have 1 and 2. So therefore, the first and the second position is going to be divided amongst these 2 occurrences of 3, which will be 1.5 and 1.5. And then we have only one time that 4 is occurring, right? So which position will 4 be in?
I think the last
3. Yes. So 4 will have the position of 3 because we have already divided the first and second position amongst the numbers 3. We have 5 left. 1, 2, 3, 4, and 5. right? So 5 will be divided amongst the positions of 4, 5,
5,
6,
6,
7,
7,
and
8,
8. Again, this totals to
30,
30.
6,
So therefore, our rank is going to be 6.
6.
So again, I'm just going to copy this. Put it right here. So x2. Right. So now we're going to calculate the difference. So again, we have 0.5, we have 0, we have 3, then we have 3.5, we have 1, then 0, 0, and 0. This is the difference that we've gotten across the ranks. Yes?
Yes.
Awesome. Now we're going to calculate d squared, which is 0.25, 0, 9. 3.5 squared is 12.25. We already
25, yeah.
calculated it where here. We already calculated it here. So 12.25. We have 1. Then we have 0, 0, 0. So we need to again total this. So I'm just going to again give some. We have 22.5 as total.
Yes, 1 second.
Yeah.
There is some problem with my screen.
That's okay. Take your time.
Yeah. Continue.
Yeah.
Yeah.
So we're again going to substitute the same thing into the formula. Right? We already calculated the denominator to be 504. So we're just going to keep it that way. Right?
Yeah.
So we're going to now go ahead and calculate this. So what do we have here? We have 1 minus 6 into 22.5 as the numerator and the 504 as the denominator. Yes?
Yes.
This is what we need to do. So now we have to calculate 6 into 22.5 first, which is 135. 135 divided by 504, which is
0.26.
Yeah. So 1 minus 0.26 is what we have obtained here. So therefore, when we do the same calculation here, 1 minus 0.26.
It is 0.74.
Exactly. So the correlation value here is 0.74. So when we say 0.74, now what will be our interpretation of this?
This is
correlation?
moderately correlated.
Yes, it is still something that is significant for us with regard to the values. So therefore, we can still say that for even this dimension, our scores are still having high test-retest reliability. Does that make sense?
Yes.
Any questions on this?
No. So we will do this correlation for each construct separately. And
Yeah.
overall, how do we check the reliability for the scale?
That depends on the scale. For this particular scale, we do not have a total score. We do not have a global score. So therefore, we need to go by dimension to dimension. But if your test does have a global score, we will again have a list of this global scores like this. So you can just correlate the global scores and get one total value.
Okay.
So it just completely depends on the nature of the test. So since this only has dimensional scoring, we are only going to take the dimensional scoring.
Okay.
Any other questions?
No.
Awesome. Ishani ma'am, do you have anything else to add on to this?
I think nicely you have explained.
Thank you, ma'am.
So maybe on usage ground, if Dharani have any questions or like where exactly these are used and all, then those can be answered.
Any questions on those lines?
Maybe the practical application of this. Where do we, while tool construction, it is useful, right?
Of course, of course.
Other
Yes.
than construction of the tools, where can we?
When we talk about construction of tool here, this particular methodologies does not just limit itself to creating the tool. This methodology is also useful when you're trying to establish norms for various other populations, right? So if you're trying to expand a foreign tool to our population, let's say the Indian population, then we will have to get certain scores like this and then test the reliability, right? So therefore, we will have to go ahead with certain mechanisms like this to establish that reliability. And retest reliability is the easiest way to examine the consistency of scores that we're getting. Apart from this, of course, I think Ishani ma'am also spoke about the various kinds of reliability, where the inter-rater reliability and Cronbach's alpha, the internal consistency coefficients, and so on. So they are also pretty important, but this will give us a clearer idea with regard to an easier understanding of which ones are the good items here and which ones need to be changed and how it needs to be worked out.
Yeah, right, Anindita. So as per the context or as per the situation of your research, when we are kind of adapting to some of the tools or say questionnaires, that time this is much more usable.
Yeah, and it is not just limited to using our Spearman's rank order correlation. We can also use various other methods of correlation, like Pearson's correlation as well, in order for us to determine this. We are taking rank order correlation here because it's easier for us to calculate the values with such limited data. That's all. Because Pearson will assume normality.
Yeah, okay. Thank you.
Awesome. Sir, would you like to add anything to this? Because I've completed the portions that I'm supposed to teach today. Sir?
It seems.
Hello.
Yes, sir.
Good evening, sir. Would you like to say anything and share anything, sir? Because I've completed the portions that was assigned for today.
Okay. So Dharani, is it clear to you that is why instead of the product movement correlation, Madam has used the rank order correlation?
Yes, sir. Yes, sir.
Hello, Dharani.
Yes, sir. Yes, sir. Hello.
This is clear, right?
Yes, sir. Yes, sir.
And have you observed the paired rank procedure, paired rank principle?
Yes, sir. We just taught them that as well. The paired ranks is the methodology that we use to calculate the ranks. This one.
Yeah.
Can we end the session a little early today, sir? Because
Yes, now you can end the session.
okay, sir. All right.
Okay.
Thank you so much. Please try and do the assignment. We'll assign it shortly.
Yes. Sure.
Awesome. I'll also share one more tool with you that has been developed by sir. So we'll do the assignment based on data collection from that tool. So I'll keep you posted on the information through Google Classroom.
Okay.
So
we
have
to collect data using that tool,
and
those scores we will have to calculate and.
So for retest reliability, we will send you certain scores. You collect the data using that tool and we use it for validity. I think we can take that time to use it for validity.
Okay.
Yeah, so this week actually all of you can use this tools once shared for collection of data, because Friday we will do the theory part of validity, right, Anindita?
Yes. Yes, ma'am.
So next week, I think we will come to the practical aspects of validity. Before that,
Yes.
the data collection can be completed.
Yes,
There is
ma'am.
enough time.
Yes, ma'am. That will be fine.
Anindita, request to you, when you will be sharing the tool in our Google platform, please
Yes,
mention
ma'am.
that next week we expect all the participants to complete that assignment,
Yes,
because
ma'am. I
next
will do
week,
that.
yeah. Okay,
Yeah,
thank you.
I will do that. Thank you, ma'am. Okay. Good night, all. Good night, sir. Good night, Dharani. Thank you so much for joining.
Om Purnamada Purnamidam Purnamudachyate Purnasya Purnamadaya Purnameva Vasishyate. Om Shanti Shanti Shanti.